Hi, welcome to Physics Teacher. In this grade 11 chemistry tutorial, I'm going to go over everything you need to know about nomenclature in grade 11 chemistry. Make sure you stay till the end because I'm going to give you a little quiz. So let's start with ionic compounds. Specifically, we're going to start with binary ionic compounds. Binary just means two. Now, when you have a binary ionic compound, let's start with something simple, NaCl. To name a binary ionic compound, you're first going to name the metal, sodium in this case, and then you're going to change the name of the non-metal to an ending of IDE. So chlorine becomes chloride. So NaCl is sodium chloride. Let's try another one. How about MgF2? Again, we're going to name the metal, so Mg is magnesium, and then we're going to change the ending of the non-metal to IDE. So fluorine becomes fluoride. Alright, so where does this 2 come from then? Because we don't say there's a 2 in our naming. Well, let's look at that. If you're to have magnesium on the periodic table, you can see that magnesium has 2 outer electrons. Fluorine has 7 outer electrons. Now, an ionic compound is a give and take relationship. So fluorine is going to take one of magnesium's electrons. So now fluorine has a full outer shell. It is happy. Magnesium is not. It still has this 1 electron to get rid of. So we need a second fluorine atom in order to make all of our elements happy or stable. So that's why we have 2 fluorines. Now you can also check this with the charge. So if you look at your ionic charge for magnesium, that's going to have a charge of +2. And for fluorine, we'll have a charge of -1. So what you want to do is you want to have a number of fluorine atoms and magnesium atoms so that the total charge is balanced. So in this case, with 2 fluorines, our total charge is -2. And with magnesium, it's +2. So that's where your charges are going to balance, and we need 2 fluorines. Another way to do it is what we call the crisscross rule. So you can do, say, magnesium, which is +2, and fluorine, which is -1. And we can cross over the charges, not the sign of the charges, it's the charges. So we would have 1 magnesium and 2 fluorine. Now, if you're going to do this, you have to make sure you then take the lowest factor. So what do I mean by that? Let's go over another example. So magnesium oxide. So let's try and come up with the chemical formula for magnesium oxide. So looking at our periodic table, magnesium has a charge of +2 and oxygen has a charge of -2. Now if you're to do the crisscross rule, you're going to get 2 magnesiums and 2 oxygens. But you have to put that into its lowest common factor. So this has a ratio of 2 to 2, which is the same as 1 to 1. So we're going to reduce that to MgO. Now, if you were just looking at charges, you probably could have seen that right away, as the charge of magnesium is +2 and the charge of oxygen is -2. So we only need 1 of each in order to balance the charges. You can also look at that using our Lewis diagram, where magnesium has 2 outer electrons and oxygen has 6 outer electrons. So that oxygen will take both of magnesium's outer electrons. So you only need 1 of each. Let's try another example. How about lithium oxide? So what's the chemical formula for lithium oxide? Well, lithium has a charge of +1 and oxygen has a charge of -2. And that you just need to check on your periodic table, or if you remember the trends for the periodic table. In this case, you can either do the crisscross rule, or you can look at the charges to balance it, but it looks like we're going to need 2 lithiums and 1 oxygen. So our chemical formula would be Li2O. Next, we're going to still do ionic compounds, but we're going to specifically look at elements that have multivalences. So multivalent elements. These are our transition metals. For example, iron. Iron is a multivalent element. It could have a charge of +3, or it could have a charge of +2. So if we were to look at an example, let's say iron oxide. If you were to simply write iron oxide, we would not know which iron we are talking about. So, in order to indicate the charge or the ion of which iron we are looking at, we need to write in Roman numerals what that charge is. For example, if it's iron 3, then we will write 3 in Roman numerals. So this will be called iron 3 oxide. And then if we're to come up with an equation, just as before, we know that this iron has a charge of +3. Oxygen, using our trend in the periodic table, has -2. So you can either balance the charges or do your crisscross rule, and you will get a chemical formula of Fe2O3. And so there's the chemical formula for iron 3 oxide. Alright, let's try another example. Let's say we had lead 2 sulfide. Alright, so our charge on lead is indicated right here with the Roman numeral. So Pb, which is lead, has a charge of +2, and sulfur has a charge of -2. So we only need one of each. So our chemical formula is PbS. Alright, let's try this the other way. Let's say I gave you the chemical formula. So let's say I said PbS2. So what is the name of this? Well, we know what sulfur is. Sulfur has a charge of -2. And we also have 2 of these sulfur atoms. So we have 2 of these negative charges to give us a total charge of -4. Now for lead, we only have 1 of these atoms with an unknown charge. But we know they must add up to positive charge to balance out the negative charges. So since we only have 1 atom of lead, it must have a charge of +4. So we would name this to be lead, and then indicating its charge 4 sulfide. Alright, moving on. Again, we're still going to be sticking with ionic compounds, but now we're going to be introducing polyatomic ions. Now in most chemistry textbooks or on a sheet your teacher may have given you, you probably have a list of all these different polyatomic ions. For example, you might have chlorate on your list, and it will say chlorate has the formula ClO3 and a charge of -1. Now, you could also have chlorite, which would be ClO2 -1, and you can also have hypochlorite, which would be ClO -1. Do you notice a pattern here? So 8 is ClO3. Now if we change 8 to ite, we've lost 1 oxygen. And then if we add hypo to that, we've lost another oxygen. That will be in all the cases. For example, we could have sulfate. Sulfate has a formula of SO4 with a charge of -2. So sulfite will then have 1 less oxygen, SO3, with a charge of -2. And you can also have hyposulfite, which would be SO2. So that's just a pattern in polyatomic ions. So now what we're going to do is we're going to attach these polyatomic ions to a metal to form an ionic compound. For example, we could have sodium chlorate. So sodium chlorate. Sodium is Na and it has a charge of +1. Chlorate is ClO3 and it has a charge of -1. So we only need 1 of each, meaning sodium chlorate has the chemical formula NaClO3. Or we can include a multivalent element or metal. For example, copper, 1 perchlorate. So perchlorate, we get the per means we get an extra oxygen. So perchlorate would have a chemical formula of ClO4 and has a charge of -1. So that's what happens when we add per. So we have copper, which is Cu. The Roman numeral tells us the charge on copper, so +1. And then we have perchlorate, which is ClO4 with the charge of -1. So we only need one of each to balance the charges. So copper 1 perchlorate would be Cu ClO4. Alright, so now what would this be if I did copper 2 perchlorate? So this indicates that this copper has a charge of +2, and we know perchlorate has a charge of -1. So I'm going to need 2 of these. How do I indicate that? We are going to indicate that using brackets. So we have brackets, ClO4 and bracket, and then we have 2 of them. So copper 2 perchlorate will look like this. Next, what I'm going to do, still ionic compounds, but now we're going to add hydrates or hydrated compounds. So hydrates is when we actually add water molecules onto the ionic compounds. Now they actually get bonded to the ionic compounds. This is not dissolving ionic compounds in water. So for example, let's try and look at copper 2 sulfate. But now I'm going to add, let's say, 5 water molecules. So what I do then is I'm going to call this pentahydrate. Penta means 5. And so there is a list. These are called prefixes. And so I'm going to write a list of prefixes that we're going to use. For example, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta. And we can go up higher as well. So now if we're to write out this chemical formula, so copper, that is a charge of +2, indicated here by our Roman numerals. Sulfate is the polyatomic ion SO4 with a charge of -2. So we only need 1 of each to balance the charges. So we have CuSO4. And then we're going to put a dot or a bullet right there. And then 5 hydrates, so 5 water molecules, so 5H2O. So there we go. Copper 2 sulfate pentahydrate. So next I'm going to move away from ionic compounds and we are going to look at molecular compounds. Now molecular compounds no longer have a metal in them. They're composed of non-metals. And we are going to use the prefixes that I wrote here for hydrates to show how many atoms of each non-metal we have. So there are a couple rules. One, we're going to use prefixes to indicate number of atoms, not the charge, but the number of atoms. So to indicate number of atoms. And still, the ending of the second non-metal is going to change just as before to IDE. So ending of second non-metal, change to IDE or IDE. And the last rule is you will never use mono or 1 on the first non-metal. So these are our rules. So let's try some examples then. How about CF4? So this is carbon. Now there's only 1 carbon. So instead of saying monocarbon, we're going to observe this rule that says don't use mono on the first non-metal. So we're just going to write carbon. And then we have 4 fluorine atoms. So we're going to indicate the number of fluorine atoms with our prefix. Over here, 4 is tetra. So we write tetra. And then change fluorine to fluoride. So we're changing the ending again to IDE. So CF4 would be carbon tetrafluoride. Let's try another one, about N2O5. Now immediately you should identify that that first element is a non-metal. So this is not going to follow the same rules as ionic compounds. It's molecular compounds using prefixes. So we have 2 nitrogens, so 2 is di. So we're going to have dinitrogen. And then 5 oxygen, 5 is penta, so pentoxide. Alright, let's try one more, so CH4. So CH4, 1 carbon, but don't write mono. And then 4 hydrogens, so tetra. And then hydrogen becomes hydride. Always aim for 2 syllables when you're trying to change the ending to IDE. Don't try to say hydrogenide. Aim for 2 syllables, so hydride. Alright, so can we go the other way around? For example, if I were to write dihydrogen monoxide, can you tell me what the formula would be? Well, di tells us there's 2 hydrogen, so H2, and mono tells us that there's 1 oxygen, so O. So H2O, water. How about carbon dioxide? Well, this is our first element, and there's no prefix, meaning there's only 1 of them, so that's just C. And then we have 2 oxygen, CO2. How about carbon monoxide? Well, we have 1 carbon and 1 oxygen, so CO. Lastly, we're going to talk about and look at naming acids. Now we have 2 types of acids that we're going to name. We're going to name binary acids, and we are going to name oxyacids. Now for binary acids, again, in the name binary, meaning 2, we're going to have hydrogen, because we need hydrogen for an acid, because we need those hydrogen ions dissolved in water. So all acids will be in an aqueous state. So for example, HCl, and of course aqueous. We need to write that. Alright, so HCl, well, let's first look at what HCl would be if it's not aqueous. Well, that's a molecular compound. So we have hydrogen chloride. Now, yes, it's not technically wrong to say hydrogen monochloride. But in this case, because hydrogen so often acts like a metal, we're sort of naming it using those rules from ionic compounds. So we normally just say hydrogen chloride. But once we mix it with water, or once we dissolve it in water and we get those ions, it becomes an acid. So how are we going to name the acid? The acid, we're going to start by writing hydro. And then we're going to use chlorine, but we're going to change the ending to ic. So it's going to say chlor-ic. So the ending becomes IC. So with binary acids, we get hydro and then ic, acid. We need to end with acid. So HCl, aqueous, is hydrochloric acid. Let's try another one. How about HBr? Again, aqueous. Alright, so this is a binary acid. So we're going to start with hydro. And Br is bromine. So we're going to end with bromic. We're going to change the ending to ic. And then acid. Alright, let's try one more, but we're going to go the other way. Can you write the chemical formula for hydrosulfuric acid? Alright, since we have hydroic acid, then we know that sulfur is combining with hydrogen, and it's going to be an aqueous solution. So, hydrogen, you write this over here, hydrogen has a charge of +1. Sulfur has a charge of -2. So we're actually going to need 2 hydrogens. It's similar to how we figured out the formulas for ionic compounds. So we're going to have H2S, and that is going to be an aqueous solution. Next, let's look at oxyacids. Now, oxyacids, just as the name say, contain oxygen. And those oxygens are going to come from polyatomic ions. So, for example, let's say we have H2SO3. So SO3 is the polyatomic ion sulfite. Now, with an acid, if it's an ite, we are going to change the ending to us. So this becomes, instead of sulfuric, we're not going to do the ic, it's going to be sulfurous acid. And the reason why we know that sulfurous acid contains oxygen is because we don't put in hydro in the beginning. Hydro always goes with binary acids, not oxyacids. So this just becomes sulfurous acid. However, if we were to have H2SO4, and I'm forgetting my aqueous, we need that aqueous there. With H2SO4, this is sulfate. Anything that ends with ate is going to have its ending changed to ic. So this becomes sulfuric acid. Alright, let's try another one. How about HClO3 aqueous? Well, ClO3 is the polyatomic ion chlorate. Now since it ends in ate, we're going to change that ending to ic. So this is going to become chloric acid. So how would I write, for example, chlorous acid? Well, for that, you need the polyatomic ion ClO2. And since its charge is -1, it's going to have 1 hydrogen to balance the charge, and it's going to be aqueous. Alright, I hope you enjoyed the video, and I hope you've learned something. It's quiz time. So I'm going to give you 6 questions. Let me know your answers in the comments, and we'll see how you do. Question 1, MgF2. Question 2, P2S5. And question 3, FeCl3. So tell me the names for those compounds. Question 4, we're going to do the opposite. I'm going to give you the names and you tell me the formula. Number 4 will be perchloric acid. Number 5, calcium sulfate dihydrate. And number 6, copper 2 sulfate. Alright, give them a try, and if you like this video, be sure to subscribe to support more.